this, which is you take each of your data and divide by the total, right? And again, if you want to check, you can always take each of this relative frequency, you take each of this thing here, you add them up to see if it's equal to 1. Most of the time it will equal to 1. Sometimes it might not because of the way that we round up. Sometimes you round up, some you increase and some you decrease. So sometimes it's like 0.9999 or 1.0001 because the way we round up might be a little bit off like that, but it's not a big deal. If it's close to 1, if it's all perfect number, it will be equal to 1. If we have to round up something, then sometimes it's off by point something of a decimal, so it's not that big of a deal, okay? So question with this, how to construct a frequency distribution table, a histogram, and a relative frequency distribution table. Now, let's take a look at the other one, which is what happens if they don't give you the width? What happens if they give you this data, right? What is this data? The number of hour, the following table present the number of hour a sample of 40 subscribers listen to Pandora radio in a given weeks. So looking at this thing here, again, we have 40 data, right? We have 40 data here. And they ask you for A, they ask you construct a frequency distribution with approximately 11 classes. So everybody see the difference between this question versus the previous question. The previous question, they ask you construct a frequency distribution with the width of 5 and the beginning of your data is 55. So if this is the question, how do we know the class width, right? How do you know the class width? So this author, I will base on this author way of doing it because we're using his book, so we have to adapt to his way, okay? Different author have a different way. It's a little bit different here and there, but again, this is how you want to find the class width. So first of all, we know that we need to have approximately 11, meaning we need to have 11 class, which is everybody see right here, I have 11 different class here. So we need to divide this thing evenly in terms of this. So the first thing we need to do is to find the class width. You go into your data, you're looking for the highest data value. Whatever the highest data value is, you take the highest data value and you divide it by the number of class that they wish for. If they want 7 class, you take 52 and divide by 7. If they want 8 class, you take 52. 52 is the highest data, ladies and gentlemen. 52 and you divide by 8, right? So in this case, we take 52 and we divide by 11 because of the 11 is the number of class they want, okay? And one thing about this thing here, ladies and gentlemen, statistic, we have, I think like 3 different type of routing rule. There are 3 or 4 different type of routing rule. Your original routing rule, if the number is bigger than 5, you add 1 and drop everything. That's your original item. Because of the number of class is discrete data or discrete number, we want to make it a whole number, right? We want to have how many number of data in each class. We want to have the whole number of data. I cannot have 4.7 of a data, right? So for this thing here, for the class width, you have to go up to the next whole number, okay? Even if, for instance, if this is 4.27, you still have to go up to 5 because we want to overestimate rather than underestimate, okay? We want to have extra and not have less than what we needed, okay? So whatever this number, as long as it's decimal, if they ask you for the width of your class, if it's a decimal, if it's 4.002, we still go up to 5. We want to make a 5 data, which is in this case, this one here, 4.7, we go up to 5. So everybody see, that is my class width. My class width coincidentally is the same class width that my previous problem. I should look at different problem to give you guys so we have a different class width. But coincidentally, we have the same class width. Okay, so it's not always 5, ladies and gentlemen. It's just coincident. Now, the author do this. The author do this in terms that you look at this data. You always, if you have this data, we always start with 0 as your lowest limit. Okay, whatever your data is, we always start at 0. And then from 0, you add your class width to it. Okay. So again, basically this is what we have, which is again, based on this thing here, because the lowest data is 3 in the cent, we start with 0. And then every time we move, we add 5 units to it. Okay. Whoever say 2, you're correct. 2 is the smallest data, but it doesn't matter what the smallest data is. If it's close to 0, we start with 0. Okay, he changed it on you guys, like say if the data is like 11 is the highest and your class width is like 6, then you have to start at 10. So sometimes he changed it on you guys. He are not very consistent, but based on this thing here, most of the data will be very close to 0, which is you have to start at 0. Other author, they say you start with the lowest data and then you jump. But again, I tried to do that way and it come out wrong for him, for this author. So we have to stick with his way, and that's what Connect Math does. So we start with 0, and again, our class width is 5. So everybody see that every time I jump, I need to add 5 units, right? 0, 5, 10, 15, 20, 25 to 50, which is everybody see that this thing here, this is my 11 class, right? I have 2, 4, 6, 8, 10, 11. I have 11 different class. And now what will be my upper limit here? My upper limit will be, again, 4 point, it's probably 4.9. It's probably 4.9, not 4 point, in terms of because of an hour. But again, I just make it 4 for now. But again, on Connect Math is supposed to be 4.9 and 9.9 and so on and so forth. But again, this is what we have in that sense. And once we have this thing here, just like before, the only thing different from this problem versus the previous one is the previous one, they tell you how many class they want, not how many class they want. They tell you what data to start with and what is the class width. This one here, they don't have the starting data and they don't have the class width. So to find the class width, you have to take the highest data, divide by the number of class they want. All the way round up to the next whole number. And then again, start with 0 and jump. Every time you jump, you add that class width to it. Okay, so everybody see the difference between this problem versus the previous problem where they state out what they want. This one here, they did not state it out. So you have to manually looking for those units. Hopefully I did not confuse any of you. Any question here?